All right, today we are going to start into chapter 7, and we're going to talk about ratios and rates today. This chapter is all about ratios and proportions. And remember, we've discussed this before, but the word ratio and the word rational obviously comes from the root word ratio. They both just describe a fraction, right? Because a fraction is a ratio or a comparison. 2/3 is saying 2 out of 3. If there's 3 total, I have 2 of them. I have a piece of the whole. So we use ratios to compare. If we were comparing boys to girls, we could say there's 7 boys and 5 girls in the class. Well, we could compare that by saying boys and then a colon, 7:5, or we can say 7/5, or we can say girls to boys are in a ratio of 7:5 and use the number 2. All 3 of those ways are methods of comparing 7 boys and 5 girls. We're putting them into a ratio. This way right here is sometimes seen in word problems, and this right here might also be seen in word problems. But typically when you're actually doing the work that you need to do, doing some computations with a ratio, you're going to write it as a fraction. That's the form you're going to use when you're doing a computation. So equivalent ratios are just 2 ratios that have been simplified down as low as they can go, and they match. They are the same. So let's look at a couple of equivalent ratios. Right now I could say, let's see, 6:2 is equal to 3:1, right? If there's 6 people in the class and 2 of those are teachers, then that means if there were only 3 in the class, then 1 would probably be a teacher. Those are equivalent ratios because 6/2 can be reduced down and simplified down to 3/1. So that we can say that 6/2 is equal to 6:2 is equal to 3:1. Those are equivalent ratios. And typically we'll write equivalent ratios in the fraction form. Let's look at example 1 now, and let's kind of see how this works in an actual problem. So we have a soccer team that won 10 games and lost 6. So let's say what we know here. They had 10 wins and they lost 6 games. So part A tells us to find the ratio of losses to wins. Okay, now the order that these 2 things are listed here is important. Okay, losses to wins. That means losses needs to come first. So I can say 6-10, or I can say 6/10. Okay, now this is not in lowest terms. 6/10 can be reduced. Both can be divided by 2. And I'll end up with 3/5. So 3 out of 5. So the ratio of losses to wins is 3:5. 3:5. 3 different ways again of writing that. Typically you're going to say, for a word problem like this, you're going to write it as a fraction so that you can reduce it. But then you're going to change your final answer back to this colon method, okay? So you're going to say the ratio of losses to wins is 3:5. Now, part B says determine the number of games played, okay? If we want to find the number of games played, we just simply need to add our wins and our losses together, right? And we'll see that there were 16 games played. And because we want to find the ratio of wins to total games played. So this is our first step so that we can find, let's see, can you see if I Move it down here. I don't want that glare to be on there. We're looking for the ratios of wins to total games played. Okay, so we had to add our wins and our losses together so that we know the number of games played. The total games played was 16. Wins, we had 10, so we can make a ratio out of that. 10 over 16. That will reduce by 2 again, and we'll get 5 over 8. So the answer for part B is 5 to 8. The ratio of wins to total games is 5 to 8. Okay. Now on page 270, Skill Check A gives you the opportunity to practice writing a ratio that's written with the word 2, like this, writing it as a fraction, and then writing a ratio that's written with the colon as the comparison, writing it as a fraction. And then it gives you the opportunity to look at two ratios and decide whether they're equivalent or not. Would they both reduce to lowest terms? When they both reduce to lowest terms, would you have identical fractions? If so, then those ratios are equivalent. And then they give you like a word problem. You've got the 7th grade class with 14 girls and 10 boys. Write a ratio of boys to girls, and then write a ratio of boys to students in the class. Now, if they only told you how many girls and how many boys are in there, how are you going to figure out how many students? You're going to add girls and boys together and then use that number to make a ratio. So let's look at some definitions. Again, I'm on page 270. A rate is a ratio that's comparing quantities with different units. Okay, like we're driving 75 miles per hour. Miles is a unit and hours is a unit. And when we compare those two things together, we get a rate, right? And then now a unit rate is a rate that compares a quantity to one. Okay, so let's look at how this might work. Example 2, Jenna mixed 9 drops of green paint to 6 ounces of blue paint. So she had 9 drops of green, and then she has 6 ounces of blue. Okay, so these are the two different units that we're comparing. We're comparing drops and ounces. Okay. Before we were comparing boys to girls, etc. But when we're comparing two completely different units, then we call that a rate. And the unit rate is when we reduce that down to 1. So part A tells us to write a rate to represent the mixture and then find the unit rate. So this is what we're going to do. We're going to say 9 over 6, right? 9 drops into 6 ounces, and then we're going to try to reduce that to where we have a 1 on the bottom, right? Actually, that would make it a unit rate, and we're not making it a unit rate. We're just finding the rate. So right now, we just want to reduce it to lowest terms. So what we want to do is divide 9 and 6 both by their greatest common factor, which is going to be 3. So when we divide 9 by 3, we get 3. When we divide 6 by 3, we get 2. So this tells us we need to use 3 drops for every 2 ounces. Okay? That's the rate at which we're going to mix the green and the blue together. 3 drops of green for every 2 ounces of blue paint. Now, the unit rate is when we take this rate here. So let's kind of box this in. This is our rate. Now we want to take that rate and we want to reduce it down till we have a 1 in the denominator. How do I turn 2 into 1? I divide it by 2, right? 2 divided by 2 gives me 1. So if I divide by 2 in the denominator, in the bottom, I need to do it in the numerator in the top. Well, what do I get when I say 3 divided by 2? I actually get 1.5, right? So what this is telling me is that my unit rate is 1.5 drops for every 1 ounce of paint. That's my unit rate because I'm comparing it to a quantity of 1 in the denominator. Now, this problem doesn't make a ton of sense because how in the world do you get half of a drop, right? That's not really even possible. If this wasn't drops, if this was 1.5 tablespoons of butter to every 1 ounce of cocoa or something for a recipe, it would make a little bit more sense, right? But drops to ounces, you can't really get 1.5 drops, but that's the unit rate. For every 1 ounce of blue, we need 1.5 drops of green if we want to get this mixture that's identical to what Jenna achieved when she mixed 9 drops of green into 6 ounces of blue. Okay, so we did part A. We wrote a rate and then we found the unit rate. Now part B tells us to use the rate to see how much green paint she needs to mix 4 additional ounces. Okay, so if she's going to put, if this is her rate, 1.5 drops for every 1 ounce, and she's going to have 4 ounces of blue that she mixes up. How many drops of green is she going to need to use, right? Well, 1 times 4 gives us 4. What does 1.5 times 4 gives us? It gives us 6. So we know she's going to need to use 6 drops of green for 4 ounces of blue. All right, now skill check B on page 271. It gives us some problems that we can understand a little bit better because they're rates and unit rates that we're accustomed to hearing about. And so let's take a look at one of those and then you can kind of do the rest of them on your own. But skill check B, problem number 1, says 34 miles in 4 hours. Okay, now obviously this person must be walking, jogging, something. We'll figure it out in a second. They're not driving because you're driving extremely slow if it takes you 4 hours to drive 34 miles. So what they want us to do is decide if this can be written as a rate, and then if it can, write it as a simplified rate and a unit rate. Okay, so this one can be written as a rate because we're comparing 2 different units, miles and hours. Okay, so we can write it as a rate, 34 over 4, and then we can simplify it. We can reduce that down. Both of these will divide by 2. So when we do that, we're going to get 17 over 2. Okay, so this is our simplified rate. Now we want to turn this into a unit rate. Okay, that means we want to reduce it down until we have a 1 in the denominator. So we said 2 divided by 2 to make 1. So that means now we need to say 17 divided by 2. And what do we get when we divide 17 by 2? Well, we get 8, but we have 1 left over. So we annex a 0 and we get 8.5. Normally we don't put decimals inside of fractions, but when we're dealing with rates, we can do that because it's a comparison. So here is our unit rate. Okay? In 1 hour, this person was going 8.5 miles every 1 hour. So 8.5 miles in 1 hour. If you're doing a good jog, you can probably get a mile in about 15 minutes. So there's 4 sets of 15 minutes inside of an hour. So you could probably go 4 miles in an hour if you were jogging. So 8.5 miles in an hour. Maybe they were riding a bike, or maybe they were rollerblading, scooter, I don't know. Something between walking, jogging, and a car, obviously. Now back to skill check B. Part 2 tells us that a grade of 85 compared to a grade of 92. We can't write that as a rate because we're comparing a grade and a grade. That's the same unit, not different units. So you're just going to say not a rate for that. And then number 3, it says mowed 27 yards in 15 days. You can make a rate out of that because yards and days are 2 different units you're comparing. So you can make a rate, then you can simplify it down, reduce it to lowest terms if possible to get your rate. Once you have an established rate, simplify it down till you have a denominator of 1 and you will have a unit rate. And it may be a decimal, and that's acceptable. Problem 4, you're comparing 5 feet and 4 inches to 4 feet and 10 inches. So that's like height compared to height. So you can't make a rate out of that.